For billions of years, the universe has been expanding, galaxies drifting farther apart as space itself stretches. But imagine a distant future where this expansion suddenly stops. The moment the universe stops expanding forever would mark one of the greatest turning points in cosmic history, where the long outward journey of everything begins to change in ways we can barely imagine right now. Expansion is driven by dark energy, an invisible force pushing galaxies away from each other. If this force weakens or disappears, expansion would slow down. Over unimaginable timescales, galaxies would gradually stop moving apart, and the universe would reach a state of cosmic stillness. At first, this change would be almost impossible to notice. The vast distances between galaxies would continue to increase slightly, but the rate would slow. Eventually, expansion would halt completely. For the first time since the Big Bang, the universe would no longer grow. When expansion stops, gravity begins to dominate again. Galaxies that were once moving apart may begin drifting toward each other. The balance between expansion and gravity would shift, setting the stage for a completely new phase in cosmic evolution. Clusters of galaxies would slowly start merging. Over billions of years, gravitational attraction would pull structures closer together. What was once a universe of separation would become a universe of convergence. As galaxies move closer, collisions would become more common. Massive clouds of gas and dust would interact, triggering bursts of star formation. The universe might briefly become brighter again as new stars ignite in these merging systems. Stars themselves would feel the effects. Gravitational interactions would disrupt orbits, sending stars into new paths. Some would be ejected into intergalactic space, while others would be drawn into dense clusters or black holes. Black holes would grow rapidly in this environment. As matter becomes more concentrated, these objects would consume surrounding material and merge with each other, forming even larger black holes that dominate their regions. The cosmic background radiation, once cooling as the universe expanded, would begin to heat up again. As space contracts or stabilizes, energy density would increase, slowly raising the temperature of the universe. Planetary systems would not remain stable. Changing gravitational forces would disrupt orbits, leading to collisions or ejections. The delicate balance that allows planets to orbit stars would break down over time. As density increases, matter across the universe would become more concentrated. The large-scale structure of galaxies and voids would begin to collapse, forming denser regions of matter and energy. Eventually, the universe could enter a phase of contraction. Distances between objects would shrink, and the cosmos would begin reversing its expansion. This marks the beginning of a possible Big Crunch scenario. Temperatures would rise dramatically as matter is compressed. The universe would begin to resemble its early stages, becoming hotter and denser. Energy levels would increase across all scales. Under extreme conditions, matter might break down into fundamental particles. Atoms could no longer exist as they do now, and the universe would transform into a dense, energetic state. Time itself could behave differently in this phase. As space-time curves more strongly, the flow of time might appear to accelerate toward a final point of collapse. The moment the universe stops expanding forever is not just an end, it is a transition. Whether it leads to collapse, rebirth, or something entirely unknown, it marks a turning point where the fate of the cosmos shifts from endless expansion to a new and mysterious future.